Welcome back to the SupderDataScience series on Pyspark. In this episode, we are going to be looking at just getting started with a few main operations within Pyspark, specifically related to Rdd'S, or Resilient Distributed Datasets. We're going to get to them in a moment. But what I want to also mention is, the intention of the series is to get you a decent working knowledge of some general operations, really how to get started utilizing Pyspark and its advantages. So in the next and upcoming tutorials, we can do some really fun and interesting projects and really focus on unleashing the power of Pyspark and what it's capable of. So let's get started and dive into this one. We're going to just take a look at some general information on Pyspark, which you can see here. If you visit this website, we're going to start looking at Resilient Distributed Datasets, or Rdd'S, since it's such a crucial element. I guess you can compare it a little bit to if you've worked maybe with pandas before, like a data frame. It's really how we're going to be working with data across Pyspark. And you can see, as it says in an overview, at a high level, every Spark application consists of a driver program that runs the user's main function and executes various parallel operations on a cluster. The main abstraction Spark provides is a resilient distributed dataset, which is a collection of elements partitioned across the nodes of the cluster that can be operated on in parallel, which, if you think about it, is going to be very powerful, being able to operate on nodes of the cluster in parallel functioning. So if we want to actually get down into the main part of the Rdd, we're going to scroll up. And I just want to mention it really quickly because I do think it's important just to see for Pyspark. And I recommend, always coming here, taking a look, because it gives you, Scala, Java, Python. We're going to be focusing with Python, and some examples. But to mention it and to look at here, Spark revolves around the concept of a resilient distributed dataset, which is a fault-tolerant collection of elements that can be operated on in parallel. There are two ways to create Rdd'S: parallelizing an existing collection in your driver program, or referencing a dataset in an external storage system, such as a shared file system, HDFS, HBase, or any data source offering a Hadoop input format. So in our tutorial, we're mainly going to be looking at two ways of operating this, which are going to be creating the Rdd in Pyspark, either parallelizing a list or reading from a repository. So it could be a file or database. And in order to do so, we're going to be working in Jupyter Notebooks. So let's go to the terminal and launch the command for a Jupyter Notebook. Now I'm going to pause this once I launch my command for Jupyter Notebook so we can get it set up, and return once we're in the notebook, and we will start working from there. Okay, so we have our Jupyter Notebook open. Now we do need to run a quick import statement. We need to take Spark context, which we're going to use next, but you'll see from Pyspark import Spark context. Now we need to use the next to get it set in a Jupyter Notebook. Is basically we're setting, we need to create the SC keyword to have Spark context get or create. So you're going to use the following command, which is going to set SC Spark context dot get or create. Well, we need this just to be able to operate. Since we're not working strictly in a terminal, we're actually, we are, but we're using the interface of the Jupyter Notebook, so we're going to use this command. Now, to get started with our Rdd'S, we're going to start by building a list, essentially. And if you're familiar with Python, it's going to be a pretty simple step, but if you're not, no problem. Basically, we're going to parallelize a list. So we want to set, we're going to be working with data. So let's call it data for the keyword. Equals sc.parallelize, and now we're going to create a list. So we can create it of what you want. Let's take, for example, working with names. Since it's simple, we'll do just a couple for demonstration, and we'll set a value to go with each one. Now we need to add a comma. If you work with lists, again, it should be familiar. Let's create two more. So we'll go with, we'll stick with J's. We'll go with Jason. We'll do 150. Now we'll do one more. We'll go with, we'll go with Jack. And we'll set Jack for 200. All right, so we need to run that. All right, so we have a list, which you'll see in the future. Basically, you can pull and access data from that, indexing, etc., etc. And another method of working with RDDs is to read from a file or a database, which is, again, a very familiar operation. So let's see. Let's take we'll stick with data. We'll go data file. All right, data file, since we want to pull it from somewhere. Again, we have to use sc command. It's going to be sc dot backslash. We need a text file, and then you're going to put in the direction of the path, of where it comes from. Pretty similar operation if you've worked with data files before. You just use sc, and we're pulling it from a text file. And once you have the text file, sc, you can open up a pair of parentheses. You can then add your path into the text file. If you do that, you'll be able to work with it from a text file. But for now, we're just going to comment it out, and we're going to continue working with our RDDs. We want to be able to pull values from our parallelized list. Similar to indexing with Python, although RDDs don't allow for specific or direct indexing, you would say. We're going to create this quick example so you can copy whatever list that you created. You don't have to use my exact values. You want to pass your own, add a longer list. That's up to you. But I just switch around the keyword for it. We want to make just the example. And in the end, we're going to add dot collect. And I just want to print out what the data structure of the RDD looks like. And you can see just directly from our list, similar to Python. Now we want to have this commented just because I was running some demonstrations before. Remember, in Python, the indexing and with Pyspark, the values will start at 0. So 2 should bring us back to Jack, at least the values of Jack. So let's run it, and it does. It brings us back Jack with 200. As you can see, this is a pretty straightforward approach. You're familiar with Python. It's kind of a usual operation of working with data. The interesting thing to take note out of this is that RDDs within Pyspark are schemaless data structures. A main benefit, since we were working with Pyspark, is that you can access the data in an object as you would do with Python. So it will give a benefit for those who have worked with Python before, and if you haven't, Python is such a fantastic language, specifically for data science, for artificial intelligence, machine learning, and just an all-around fantastic language to work with in general for technology, for computer programming. So it's beneficial in this tutorial that you'll be able to take away some information working with Pyspark and Python in general. And to do one more quick operation just to get you familiar with a little bit of the data with both Pyspark and Python, we're going to create our data. Let's call it data second. And we're just going to create another list. Let's do referencing the Pyspark documentation 3, 4, 5, 6, 7, 8, 9, and 10. All right, let's run that. And with the keyword of dist data equals c.parallelize, we want to pass in our data second, our list. We're going to run it. Okay. Now, for example, because of dist data, the distributed data set can be operated on in parallel. Now, again, to demonstrate, let's try dist data.reduce. We'll work with lambda, A, B, A plus B. And what it's doing is adding up the elements on the list. It can be used further on in operations. And one key note to take away from RDDs, and this, again, I highly encourage you to take a look at the Pyspark documentation. An important parameter for parallel collections is the number of partitions to cut the dataset into. Spark will run one task for each partition of the cluster. Typically, you want 2 to 4 partitions for each CPU in your cluster. And to demonstrate this, or to show you, to finish up our video before we move into the next one, Typically, you want 2 to 4 partitions for each CPU in your cluster. Normally, Spark tries to set the number of partitions automatically based on your cluster. However, you can also set it manually by passing it in as a second parameter to parallelize sc.parallelize data. Note, in some places the code uses the terms slices, a synonym for partitions, to maintain backward compatibility. I want this to be, just a quick, easy tutorial of getting familiar with some of the operations, working with data, since it's a crucial part of really any kind of machine learning, data science, AI operation. If you can't access your data or if you can't work with it, you're going to have trouble running the algorithm or building your project in general. So being able to manipulate and work with data is a key piece. You see the RDDs, or at least you're becoming more familiar with RDDs in Pyspark. And we're going to continue to move on in the next tutorial and expand upon this and get into some other operations within Pyspark on a basic level, so we can keep building from there. What I also do recommend is to check the Pyspark documentation as we're going through this, just to help you become even more knowledgeable about this. And as always, subscribe to the SupderDataScience channel, where you will get up-to-date weekly information on what's going on in the industry. There are some fantastic courses, opportunities, information, all accessible through subscribing to the SupderDataScience team. All right, that being said, let's move on to the next video, and we will continue from there.